Thank you, Chuck. Chuck characterized my research hat role at ASU pretty well. I do research in Mekong Basin and in Southeast Asia and the Indus and in the Amazon, and I just came from Ecuador on a dirt road yesterday. So I do get to go to pretty nice places. I also work in the Office of Research, which is called Knowledge Enterprise Development at ASU, where I manage the water funding portfolio for ASU, the water research portfolio, and to a certain extent, that's what I'm going to talk about today in batting cleanup. My comments will be focused on R&D needs that can improve resilience of manufacturing in the U.S. And this is from two sort of standpoints. One is resilience, so infrastructure, maybe some aspects of corporate sustainability, which I work on with many of these folks at the table here. And the other is manufacturing itself, which includes technology needs. So there's kind of two aspects of it. One is, what do I need to be more efficient? And the other is, how do I make a watershed work such that it delivers me the water I need when I need it? And those are the 2 points that we really need to focus on here. And when we get into R&D, I think it's important to think about TRLs, technology readiness levels. I'm going to talk about a couple of examples that span the scope from TRL 1 to 12 and programs and needs that fit in those categories. And all of them involve collaboration with government agencies, with NGOs, and with businesses. In fact, I work with Tim on a couple of these projects. I work with Coca-Cola. I work with a number of companies that use a lot of water or create technologies that help us be more efficient with water. So at the TRL 1 level, I'm going to start with the National Science Foundation and put a plug in for a couple of programs I think are really important. First is the NSF has a multidisciplinary research program called Critical Resilient Infrastructure Systems and Processes. I mean, how more appropriate could you get than that for this topic? It's a program that combines resources from computer science, from engineering, and from social science directorates, so it's multidisciplinary. As the name suggests, it focuses on infrastructure, but more specifically on improving the coupled resilience of infrastructure across different Department of Homeland Security infrastructure sectors. Okay, so at ASU, we actually have a new CRISP award that's in Texas. We work outside of Arizona sometimes. And this CRISP award is focused on how we might use computational approaches to improve the resilience of infrastructure in manufacturing in the petchem area and in agriculture. So it couples water, petchem, and manufacturing and agriculture at the same time. So Tim's involved in this, and I think we'll continue to engage them, even though this program is at a very low TRL. Right? So it's important to start with those basic ideas with application in mind at the very beginning. The need that I want to put a plug in for is to continue programs like this, because these programs, the multidisciplinary ones, and especially those that involve computational approaches, are going to be so critical to improving the resilience of systems that to deliver water to folks like Tim and to folks like Steve at Intel. So any programs where we can leverage computer science in a multidisciplinary way to focus on manufacturing needs are going to be important, and I think these programs hit that. Second NSF program, which takes us into sort of the second category of TRLs, this is probably in between the 3 to 5 range, are the engineering research centers and other center scale funding that NSF has, including science and technology centers. Two good examples of ERCs. The first one is an ERC called Renew It, which is based at Stanford in collaboration with Colorado School of Mines, in collaboration with UC Berkeley, and it's focused on natural approaches to water treatment that are more energy efficient. So we talked a little bit about the water energy nexus before. Stanford's Renew It is covering some of those topics. Second one is one that we at ASU participate in, but is led by Rice University, also in Texas, called NEWT, which looks at nano-inspired technologies for water treatment. So, leading edge technologies, the next gen technologies for treatment, and some technologies that are pretty scalable but also portable, and would address some of the concerns that we actually haven't talked about much, which is water supply in rural areas. Let's see. So the need here, it's pretty obvious. Continued funding for center scale activities. Science technology centers coming up pretty soon. That competition should be announced pretty soon. ERCs are providing excellent basic research that's kind of in between basic and market-ready research for various water technologies. Okay, in the same vein, same TRL level, the Department of Energy has a lot of programs in this space. One that we have recently participated in is in the area of the water energy nexus. They have a program called Clean Energy Research Centers, CERCs, and the last CERC competition, which was funded a year and a half ago, was on the water energy nexus. It was won by a team based in California. We competed for it unsuccessfully, but had a great go at it. The CERCs are a great example of sort of the innovation ecosystem, I think that Sherry was talking about before. In this case, CERCs are binational. They're Chinese. They're bilateral China-U.S. research centers. So that's also an important endeavor to think about, because challenges like Tim said that we see abroad can resonate and also bring in new technologies that we can use here in the United States. So the need there, just to, now I see my 1 minute warning, is expansion of DOE's water energy nexus programs, especially those that get us to the point of regional hubs that are innovation ecosystems and allow us to collaborate with folks like those at the table and create these pipelines of basic ideas to market-ready technologies. Also in that same bucket, the Clean Water Hub, which just came up, I think fits that bill. And the solar thermal desal program is a clear win-win for water and energy, and will provide some basic funding for research there as well. And then the final thing, and probably the most to the point of manufacturing, are I think what are being called now Manufacturing USA hubs. Okay, these are important ecosystems, big ecosystems, that'll allow folks like me and my colleagues to interact with folks that are at the table and agencies to create market-ready solutions for some of the manufacturing challenges that we're facing right now. So put a plug in for those. Those can be sponsored by many different agencies or collaborated on by many different agencies. And so to a certain extent, they're very interesting because they bring the perspectives of those different agencies as well as the different sectors that are involved with that research. And so with that, I'll close and thank you for listening.
Thanks, John.